Okay, so if we are talking about slope and the rate of change, the definition of slope, just in kind of our own words, is the measure of the steepness of a line, okay? So what is slope? A measure of the steepness of a line. And I know that some of this is going to be a repeat for us, but that's okay. So it says, what are the 4 different types of slope? And the first one is a positive slope. And that you can just draw a line, goes up from left to right every single time. Positives will always go up from left to right. Negative slopes will go down from left to right. Then we have those zero slopes. Now, zero slope is a flat line anywhere on the coordinate grid. And then the last one is undefined. And undefined are those vertical lines, straight up and down. Okay. Now, we can find the slope a few different ways. So for example, if we have a graph, the method is to pick 2 points. On the line. And the one way to do this is like to connect them, making a triangle. And then you are going to count the rise and run. So it is expressed rise over run. And I am actually going to do an example over here. I put 2 dots at -2, -2, and 1, 0. Obviously, your line will already be there if you were using this method. So it says, find your 2 points, make a triangle. That was an up movement of 2. And then I would go over 1, 2, 3 units. So in this case, your slope equals 2 over 3. Okay. Finding the slope from a table. And I'm going to start by putting my example in here. So my example is 4, 6, 8, 10, then 5, 10, 15, 20. Okay. So the first thing that you would do is to count the change in y values and the change in x values. Okay, so let's do that really quick. 5 to 10 is 5. 10 to 15 is 5. 15 to 20 is 5. 4 to 6 is 2. 6 to 8 is 2. 8 to 10 is 2. Okay, so then the next thing you could do is write as a fraction and what this is going to look like is your change in the y values over the change in x values. Now ours was the same every single time, but sometimes they're different. So the change in y was what? What was our change in y, guys? 5. And what was your change in x? 2. So guess what? There's your slope. Okay, the last way and finding the slope from 2 points, you could technically do this from a table too, because 4, 5 is a point and 6, 10 is a point, so we could do this the same way. But you are going to substitute the coordinates into the slope formula. And I'm just gonna show you how we have like x1, y1, x2, y2. Our slope formula is y2 minus y1 over x2 minus x1, change in y over change in x. And then I'm going to do an example with you guys here too. This will kind of bring back memories from the other day when we did this. Remember, one of the first things I do is label x1, y1, x2, y2. So this would be 5 minus 3 over negative 6 minus a negative 4. 5 minus 3 is 2. And then remember, if you subtract a negative, it ends up going to addition. So we've got a negative 6 plus 4. That gives us a negative 2. And then you just have to simplify. So we end up with a negative 1. That's how we use the slope formula. Okay. Okay, so the next part, we're going to talk about the rate of change. Now, the rate of change is technically the same thing as a slope, okay? So what we're going to do is we're going to just define it as that, but it's basically the real world. So the rate of change is slope in the real world. Okay, how fast something's happening, the rate somebody's getting paid, those types of things. Okay, So we have a couple examples that we are going to do together, just using the skills that I just talked about on the previous page. The first one, it says find the slope of a line that passes through these points. So we have 2 points, x1, y1, x2, y2. We're going to use, if you look back, we have 2 points, you're going to use your formula, okay? So y2 minus y1 over x2 minus x1. You don't have to rewrite that formula every single time, but some people think that it's helpful so that you remember it. My y2 was 4. My y1 is 8. My x2 is 2. My x1 is a negative 5. Like I said before, if you don't feel comfortable doing your basic subtraction with positives and negatives, go ahead and use that calculator. Make sure you get these right. 4 minus 8 gives us a negative 4. When you subtract a negative, we end up adding. 2 plus 5 is 7. Negative 4/7 cannot be simplified, so that's our answer. Okay, finding the slope from a graph. We are just gonna kind of make that triangle. You're kind of giving yourself directions from one point to another. These points were defined for us because they're perfect intersections. So we went up 1 unit and to the right 1, 2, 3 units. So it was a positive 1/3 for your slope. Going to the next one, we have a perfect intersection here. And then if you look at our grid, we actually have perfect intersections the whole way. So to get from one point to one point, I would go down 1 unit. So that would be a negative 1. And then right 1 unit, which is just a positive 1. You can simplify that to a negative 1. Okay. Number 4 and 5, they gave us some tables. And so we can do what I did in the previous example, and we can find the difference between the x values and the y values. So for example, 5 to 9, it was a difference of 4. 9 to 13 was a difference of 4. 13 to 17 is 4. 21 and 21 to 25 is 4. Okay, then our y's, it went down by 2, looks like every time. Okay, so remember with these ones, the change in y over the change in x. Because remember, y is your rise and x is your run. Negative 2/4. Yep, so we just put negative 2 and then over 4. But remember, if you can simplify, you need to simplify. Yep, so this reduces to negative 1/2. Very good. Okay. The next one, if we went from -5 to -6, or went to -7, what's happening there? Pardon? Are we minusing 1? Yep, so pay attention if you're adding or subtracting, we are taking away 1 every time. Okay, 3 to 6, 6 to 9, 9 to 12, what's happening? We're going up by 3, right? Okay, so again, change in y over change in x. So change in y was 3. Change in x was a -1. 3 divided by -1, that's -3. Okay, number 6, use our formula, x1, y1, x2, y2. y2 minus y1, so 12 minus 2 over 2 minus 0. 12 minus 2 is 10. 2 minus 0 is 2. Remember to simplify it. So 10 divided by 2 is 5. So your slope is 5. Okay, so that was kind of our guided practice. Finding slope from a graph. Should we do a few of these?
Yeah.
Yeah? Okay. So remember, we'll do line 1, then we'll do line 2 and all of them. You're looking for that perfect point of intersection. You only need 2 points. So like when I look here, I would just be like, okay, I like this point and this point. Okay, so I am going to go, I always start with the one on the left. I'm going to go up 2 units and then right 1 unit. So then when you write it, it's 2 over 1, which reduces to just a 2. Okay, then my other one, if I was going to look for nice intersections, I would have like one right here, one right here,
One by the four.
oh yeah, but that's from that other line, right? Okay, so let's take a peek at this. So this one is going to be down 1, so negative 1, and then right 2. Okay, and this is something that we'll talk about later on in our chapter, but I want you guys to kind of pay attention to the fact that this is a perfect 90-degree angle. Look at our slopes. Look at the difference between them. Okay, so let's do line 3. Line 3, let's see, probably right here. And, oh, sorry. I'm having trouble finding them on line 4. Sorry, line 3. I would say right here and here, maybe? What do you guys feel about that?
Yeah.
Okay, so I would go up 1 and then to the right 3. So up positive 1 to the right 3. Oh, I see. It's right here. Kind of beyond there. So again, I am going to start from the left point and I'm going to go down 1, 2, 3, 4. And I'm going to go to the right 1.
Is that negative 4?
Negative 4. Yep, you're right. Negative 4. Positive 1. I moved right, and that's a positive. Okay. Any questions on that one? Okay.
Can you use that to negative?
You could. Yep. If you want to just write this as a negative 4, go right ahead. Okay. Couple more here. Line 5 first. Just got a little bit smaller of a grid box, but it doesn't matter where you start. This one, to go from left to right, I went down 1, right 1. So down would be a negative 1, right is a positive 1. Negative 1 over 1, which simplifies to just 1. Oh, negative 1, sorry. Negative 1. And then if I were doing line 6, same type of thing, but opposite. I went up one, right one, up one, right one, up one, right one. So 1 over 1 gives you a positive 1. Okay. Our last one. Now this is a little bit tricky. If you think of these on a graph, I mean, you guys should be able to visualize these, right?
Oh, so then the line 7 would be undefined and line 8 would be 0?
Yes. So if you want to do these like point to point, you line, here, we'll do line 7 first. If you did point to point, the rise would be like 1, the slope would, or the run would be 0. So this is undefined. Because you would go up 1, but not over at all. So it's undefined. And then the other one, you would go up 0 over 1, which would just be 0. So that's like, technically speaking, that's how you could think of it. But you guys are going to just have those kind of in your memory. Okay, so as far as the finding slope from vertical line, input, output, we're going to skip our flip chart for now. You can fold it if you'd like, but we kind of have already reviewed that. So I'm going to save it to come back to. This is going to be your practice right here. Okay. You have a front and a back. On the back is just using that equation.